To write the Lewis structure for AsO4 3-, first thing we need to do is count up the valence electrons. So As is in group 15, sometimes called 5a. It has 5 valence electrons. Oxygen here, group 16, sometimes called 6a, 6 valence electrons, and we have 4 oxygen atoms. And then this negative sign, this 3-, negative, electrons are negative, so this means we have 3 more electrons. So let's add those. So we have 29 plus 3, 32 valence electrons for the AsO4 3- Lewis structure. So As, that's less electronegative than the oxygen here. We're going to put that at the center. And then we have 4 oxygens. We'll just put them around that central atom. Next, we'll put electrons between atoms to form those chemical bonds. Put them here. At this point, we've used 8 valence electrons. We have a total of 32. Let's complete the octets around the oxygen atoms. At this point, we've used all 32 valence electrons. Each of the oxygen atoms, they have octets, so that's good. And then our central atom, that also has an octet. So this is a pretty good Lewis structure. But if we calculate the formal charges for each atom, here's what we'll find. Each oxygen is going to be -1. The central arsenic atom, that's going to be +1. So we can do a little bit better than this. We'd like these to be as close to the charge on the ion as they can be. So what we can do, let's change this oxygen here. Let's move this pair of electrons between the oxygen and the arsenic atom. So when we do that, we have a double bond. Now our formal charges, and now we'll have a formal charge of 0 on the oxygen and 0 on the arsenic atom. So this is considered a more favorable Lewis structure because the formal charges are closer to 0, while still having the -1, 2, 3, the charge on the ion. So this would be the best Lewis structure for this AsO4 3-. We should put brackets around it and then write 3- on the outside since it is an ion. And that's it. This is the Lewis structure for AsO4 3-. And this is Dr. B. Thanks for watching.